Okay, lesson 3.2.1, summing it up. We're going to learn about sigma notation here. And so a lot of times sigma notation is used to sum things rather quickly. So we're going to learn how to do that today and what that looks like. So it starts off in question 85, starts with a little sum race where you're taking the number 2 and plugging it in and going all the way to 20 and keeping track of this. So obviously this would take very time consuming. So what we're talking about doing here is taking t to the n, or t of n, equals 0.01 n plus 1.7. And so we're saying start at 2, plug it in and go. So you would basically have 0.01 times 2 plus 1.7. And you would get 1.72, right? And you would keep going. So then you would do 3. You get 1.73, 1.74, right? And you just keep going all the way to 20. And so obviously then you would take each one of these and sum them up, right? So you can see like that's very time consuming in the sense of what that would take. So we're going to learn sigma notation and how to clean this up a little bit. So 86 says then evaluate each of the following expressions for the sum below. So what we're going to do is add up these. And so now same concept. We have t of n equals 0.5 times 0.5 n plus 2 squared. And so one time we're going to do this from 0 to 3. So we're going to start at 0 and we'll go from there. So we're going to plug in 0. So that would be 0.5 times 0.5 times 0 plus 2 squared, right? So we'll end up with 2 squared, or 4. 0.5 times 4 is 2, right? And so we'll do this again for 1. And so right here, we're going to have 2.5 squared, right? Which 2.5 squared is sorry, 6.25 times a half, right? We should get 3.125. Okay, again, we'll do this for 2. So this is going to be 3 squared, which is 9, times 0.5, okay, which is 4.5. And then we'll do it again for 3. Okay, and then the whole point of sum is to add 1, 2, 3, 4 terms up, right? So what we're talking about adding here is we're talking about adding 2, 3.125, 4.5, and 6.125. And if you sum those up, you should get 15.75. Okay, and then part B over here states that we're going to do this again, but we're going to do it from 1 to 4. Well, we already have 1 to 3, so all we have to do is to do this again for 4, right? So if we do T of 4, so we do 0.5 times 4, that's 2, plus 2 is 4. So 4 squared is 16, times 0.5 is 8. So if we add up, so then we sum up 1 to 4, so we're talking now 3.125, 4.5, 6.125, and 8. And we should get 21.75. Okay, so it asks what are the differences between those two sums. Okay, the differences are one goes from 0 to 3, the other goes from 1 to 4. And that's going to be huge when we move on to area under the curve, as we're talking left hand and right hand notation. So Math Notes talks a little bit about sigma notation and what is that letter sigma, right? It's a Greek letter used for the sum, and that's what they mean there is to sum it up, right? So they show you here an example. So you have the sum from n equals 1, 2, 3 of n squared. And you can see they plug in 1 for n, 2 for n, 3 for n. And then they add all those up. So 1 squared plus 2 squared plus 3 squared equals 14. And just a little bit of how to read that. The sum of n squared from 1 to 3, okay, where n squared is considered the argument or what you put in. And n is the index, meaning what we're going from, right? And so n must be integer values only, so it's not decimals, right? So then we look at each of the following sums in expanded form, right? And we want to write those out in expanded form. So the first one there, a is already done for us, right? So they expanded it out already here, and they just want us to go ahead and sum those. So 2 to the third is 8. Plus 2 to the fourth is 16, plus 2 to the fifth is 32, plus 2 to the sixth is 64, right? And when we sum those up, I believe we get 120, if I'm not mistaken. Okay, if you look at B there, they've started that process for you, but they want you to go ahead and finish it there. So you have the sum of n equals 3 to 5 of 4n squared plus 2. So you can see there they went ahead and plugged in 3, right? So 3 squared is 9. 9 times 4 is 36. Plus 2 is 38. Plus, if you plug in 4, 4 squared is 16. 16 times 4 is 64. Plus 2 is 66. Right? And then 5, plug in 5. 5 squared is 25. Times 4 is 100. Plus 2 is 102. And if you sum those up, you should get 206, I believe. So that's what you're doing. You get the idea there just for the sake of time there. I mean, you're doing the same things on the next ones, right? So it talks about locating the sum on your calculator. So hopefully you know how to do that. If not, there's plenty of other videos out there that teach you how to sum that up. So if we look at 88, Waylon wrote the following expression for the sum. Check out his work. Is it correct? So if we notice, we talked about up here that it had to be integer values, right? And so then we talk about there that it's decimal values, right? So so then let's talk about 89. We'll talk about subsegments. And so if we have an equal length, right, and we're going from 2 to 3, and we want to divide that into 5 subsegments, right? See, that would only be 4. So we have to do some sort of way to do this. Well, how do you do that, right? You take 3 minus 2, the distance, and divide it by 5, right? So we get a distance of 1/5, right? Each subsegment, right? So drawing an interval, like what are we talking about? We're talking about 2, 2.2, 2.4, 2.6. Sorry, I'm out of room here. 2.8 and then 3. And so it talks about what is the left endpoints, right? We're talking about 1, 2, 3, 4, 5 left endpoints. So starting at 2, going to 2.8. If we're talking about right endpoints, 1, 2, 3, 4, 5, we're starting at 2.2 and going to 3. Okay, so basically saying, is this a right endpoint starting here or a left endpoint starting here? Okay, so looking at a series, right, we're going to be able to write this in sigma notation. So if we need to write, this is for 90, right? If we need to write this in sigma notation, what we're talking about doing here is I'm going to start at 0, and notice there's 1. That would be my 0 term. So 1, 2, 3, 4. So 0 to 4 terms. You could go 1 to 5, but this just helps me when I'm writing my argument, right? So my argument, if you notice, there's a slope of 0.4, right? So 0.4 n, right? N instead of x, but like mx plus b, right? And then my starting value of 3.6, right? So that is my idea to get this sum. Okay, is using that mx plus b. Hopefully you understand how to do that. If not, we can go into more detail later. But B then asked, what would you change to make your notation go from 4 to 5.6? Well, again, that's why I started at zeros, because now I'm just going to change this to 1 to 5. So notice if I plug in 1, I'm now going to start with my first term there in the sequence is going to be 4. So then on 91, you're using the same thing, right? But you're using this same n equals 0 to some number of 0.4 n, right, plus 3.6 as my start, but they want to go to 23.6. So how would I get that? Well, I just set it equal to 23.6, and I solve, right? So I'm going to subtract 3.6. I get 20. I'm going to divide by 0.4. And I get an n value of 50. So my sequence or my sum would go to 50. Okay? So the argument stays the same because it's the same interval, right? Or it's the same argument. It's the same sum. And then the same deal if the next one wanted to go, same idea, right? So if the next one, and I can do the next one, 2.5, it's going up 0.2 every time. So n equals 0. We're 0.2 n plus 2.5. That's my start if I'm using 0. And then we're going to 22.5. So I would go 22.5 equals 0.2 n plus 2.5. Again, subtract and divide, right? I should get an n of 100 here. Okay, so same concept there.